We just wrapped up Unit 1, where we discussed lots of pretty cool things, among them the property of numbers, solving equations, dimensional analysis, and word problems. Today we're starting Unit 2, specifically sequences. So what are those? That's when we find a pattern of elements where the pattern can be named explicitly. Crucial word in there is the word elements. So frequently in this class it's going to be numbers, right? But it could be colors, shapes, even sounds. Additionally, when we're talking about sequences, we can think about this idea of future terms may be predicted. That's going to be really critical in the days and weeks ahead. In today's class, we're going to ask that you identify a sequence, categorize 3 different kinds of sequences, and in tomorrow's class, we're going to be talking about linear, exponential, and quadratic sequences. So when we look at set 1, we've got 7 different sets of sequences, and let's zoom in on these numbers right here. So when we're going from -4 to -1, what's happening? We're adding 3. And then again, when we're going from -1 to 2, and then 2 to 5, 5 to 8, and 8 to 11, we are adding 3 each time. So that's the sequence, that's the pattern. Let's take a look at this next one. If we're going from 4.0 to 3.5 to 3.0, clearly we are subtracting by 0.5 with each successive term. So subtracting by 0.5, subtracting by 0.5, subtracting by 0.5. Let's take a look at this next pattern. I see it's 2, 4, 6, 8, 10, 12. Clearly we're adding by even numbers, we're adding by 2 for each term, and so on and so forth. So what's the big idea with this? So sequences are going to grow and decay by addition and subtraction. We're going to see that pretty often. And then adding and subtracting by a constant value between each successive term, just as we did. We're adding 3 each time, subtracting by 0.5 each time. So these kinds of patterns or sequences are known as arithmetic sequences. Pretty easy. Let's switch over to transition to the next set of sequences. Let's take a look at this next set of sequences. So here I see when we're looking at the top one, we're going to start with 0.4, right? And then we're going to 0.04, and then 0.004. So what's happening between each successive term? We're not subtracting. We are getting smaller. In this case, however, we're going to be dividing by 10 for each successive term. That's the pattern. Let's look at the next one. 32 by 32, and then 16, and then 8, and then 4, and then 2. Here we're going to be dividing again. In this case, we're simply dividing by 2. So the next term would be what? 0.5, right? Let's take a look at this next sequence. I see we've got 3. We're starting with 3, and then it jumps to 9, and then 27, and then 81. And in this case, they're getting bigger, they're growing, and they are multiplying by 3 each time. So what does this mean? Sequences will grow or decay, grow meaning get bigger, decay meaning get smaller, by multiplication and division. Multiplication and division by constant values between each term is called the common ratio. So the common ratio in number 1 is division by 10, and the common ratio in number 2 is 2. The common ratio in sequence number 3 is multiplication by 3. So these are what we're going to be referring to as geometric sequences. Unlike arithmetic, these contain growth and decay by multiplication and division. Here we got our final set of sequences, and let's do a little bit of an analysis. When we're looking at this, I see that our first number is 5, right? And then it jumps to 20, and how can we get there? We could multiply by 4, but 20 times 4 is 80, and that's not what we have here, so we know it's not multiplying by 4. How else can we jump from 5 to 20? We could add 15. So let's add 15, and let's see if that holds true. 20 plus 15 is 35, but that doesn't work. That's not constant. That's not what I think is going to work. But if we add 25, that will give us 45. 45 plus what gives us 80? 35. 80 plus what gives us 125? 45. So our pattern is going up 10, 15, I'm sorry, 15, 25, 35, 45. The next, of course, would be 55. Here we've got another one. 6. How do we jump from 6 to 11? We could add 5, right? How do we jump from 11 to 18? We can add 7. How do we get from 18 to 27? We can simply add 9. So these are growing, but not by a constant. This big idea is that change between each term is not the same, and that these kinds of sequences are neither arithmetic or geometric. All right, ladies and gentlemen, we're going to continue exploring these ideas in further classes.